Welcome to mathematics class of grade 8, and this is lecture number 2 of chapter 9 Algebraic Expressions and Identities. Let us see today's topics. In this lecture number 2, we will be learning the fundamental concepts like polynomials, addition and subtraction of algebraic expressions. Though, dear children, in your previous class, you have learned how to add and subtract algebraic expressions, we will be revising or we will be recalling these operations again. And we will be learning new concepts of polynomials and its various properties and the concepts related to this polynomials. Let us recall what we have done in the previous lecture. We have learnt about the constant. What do you mean by a constant? A symbol which has a fixed value is called a constant. For example, 7, minus 3, 5 by 9, root 2, etc. All these are the examples of constant. Then we have learnt about variable. What do you mean by a variable? A symbol which can be given various numerical values is called a variable or literal. What is the other name of variable? The other name of variable is literal. So, we have learnt about the constant. What do you mean by a constant? A symbol which has a fixed value is called a constant. For example, 7, minus 3, 5 by 9, root 2, all these are the examples of constant. Then we have learnt about variables. What do you mean by a variable? A symbol which can be given various numerical values is called a variable or literal. The other name of variable is literal. For example, the formula for circumference of a circle is given by c is equal to 2 pi r, where c is the length of the circumference of circle and r is its radius. In this formula, dear children, 2 and pi, they have fixed value, so these are constants, and c and r, these are the variables or literals. So here 2 pi are constants and c and r are the variables or literals. We have learnt also about the definition of algebraic expression. What do you mean by an algebraic expression? A collection of constants and literals or variables connected by one or more of the operations of addition, subtraction, multiplication and division is called an algebraic expression. So what is an algebraic expression? A collection of constants and literals or variables connected by one or more of the operations of addition, subtraction, multiplication and division is called an algebraic expression. These are all the examples of algebraic expression. In all these, you can see constant as well as literals. Here in this first expression, what is the literal? X is the literal, 4 is the constant term and 2 is the numerical coefficient of x. Likewise, we have next expression. In this, how many terms are there? 3 terms. We have 7y is the first term, minus 3 is the second term and 6x is the third term. Likewise, 4t minus 1 is also an algebraic expression. The various parts of an algebraic expression separated by plus or minus sign are called terms. We have learnt in the previous lecture that on the basis of the number of terms, the algebraic expressions are classified as monomial, binomial, trinomial and multinomials. So, the types of algebraic expressions on the basis of the number of terms are monomials, binomial, trinomial and multinomial. What do you mean by a monomial? An algebraic expression having only one term, that is a monomial. An algebraic expression having 2 terms, that is a binomial. An algebraic expression having 3 terms, that is a trinomial. And multinomial, an algebraic expression having 2 or more terms is called a multinomial. From this table, it will be more clear to you. In the first example, there is only one term, so number of terms I have written 1. as it is an algebraic expression having only one term, so it is a monomial, and term present is this one only. In second part, two terms are there, number of terms are 2. It is a binomial, as we have discussed earlier. An algebraic expression having two terms is called a binomial, and these two are the terms. And in this there are 4 terms, that is 4, so it is a multinomial, and the number of terms are these. Then a note regarding this, we need to know the note regarding the algebraic expression. Multiplication and division do not separate the terms of an algebraic expression. Thus, minus 7x square y cube is one term. Obviously, here you must be observing, as no sign is there in between two, so we have written that multiplication and division do not separate the terms. That is why it will be considered as a single term. Only plus and minus can separate the terms. So likewise, this is your one term, plus sign is there, so this will be your second term. So it has two terms. Now constant term. What do you mean by a constant term? The term of an algebraic expression having no literal factors is called its constant term. Then in the expression, 4 is the constant term. So the term of an algebraic expression having no literal factor is called constant term. In this algebraic expression, 4 is not having any literal factor, so this is the constant term. And rest of the terms, you must be observing that here x raised to the power 5, that is x is the literal. Likewise in second term also, these are the x is the literal factor again, x square is the literal factor again. Or simply you can say in this complete expression, x in the first term it is x raised to the power 5, and in likewise you can note down the literal factors in rest of the terms, but along with 4 there is no literal factor, so 4 is the constant term. Simple as this. Simply you need to remember that the term of an algebraic expression having no literal factor is your constant term. So 4 is your constant term because it is not having any literal term attached to it. So factors, each of the quantity, constant or literal, multiplied together to form a product is called a factor of the product. So we have studied about the types of factors, that is numerical factor. A constant factor is called a numerical factor. Literal factor, a factor containing only literals, is called a literal factor. Obviously, what do you mean by factors? Each of the quantity, whether it is constant or literal, multiplied together to form a product is called the factor of the product. And there are two types of factors. One is numerical factor and another is literal factor. Numerical factor is, a constant factor is called numerical factor. Literal factor, a factor containing only literals, is called a literal factor. Let us consider this example. In 8xy square, the numerical factor is 8. And the literal factors are these. These are all the literal factors. Coefficient, what do you mean by coefficient? Any factor of a non-constant term of an algebraic expression is called the coefficient of the remaining factor of the term. The constant part is called the numerical coefficient or simply the coefficient, and the remaining part is called the literal coefficient of the term. Let us understand this with the help of an example. This is the expression I have written over here, that is 10p cube q square minus 8p square q minus 3p plus 2. This is an expression. In the term, I have taken the first term. You can find the coefficients of any term also. So, the numerical coefficient in this term is 10. The literal coefficient is p cube q square. The coefficient of p cube is 10 q square. The coefficient of 10p is p square q square. And the coefficient of q square is 10p cube. Likewise, you can find the coefficients of numerical coefficient, literal coefficient of any other particular term. So, I am explaining it again. In this term, first term, the numerical coefficient is 10, literal coefficient p cube q square, the coefficient of p cube. Other than p cube, whatsoever it is present in the term, that will be your coefficient of p cube. So, what was left apart from p cube? That is 10 q square. Now coefficient of 10p, what will be left apart from this 10p? It will be p square q square. Coefficient of q square, what will be left apart from this q square? It will be 10p cube. Simple as this. You can find out the numerical coefficient, literal coefficients of for rest of the terms also. So what is to be noted also, one more point to be noted is, if no coefficient is written before a literal, then the coefficient is always taken as 1. When we write x, we mean 1x. So whenever no coefficient is written before a literal, it will be always considered as 1. So x means 1x. Like terms and unlike terms. The terms having same literal coefficients are called like terms, otherwise they are called unlike terms. Simple as this. The terms which are having same literal coefficients are called like terms, otherwise they are called unlike terms. Let us consider these two examples. In the first case, you must be observing that literal factors are x square y. Here also it is x square y. So both are same. So these are the like terms. Now in this second example, it is ab and it is a square b. These are not same. So these are unlike terms. Simple as this. Now coming to the main topic of this lecture number 2, that is polynomials. What do you mean by a polynomial? An algebraic expression is called a polynomial if the powers of the variables involved in it in each term are non-negative integers. This point is very important to note. How will you identify that a given expression is a polynomial or not? If the powers of the variables involved in it in each term are non-negative integers. The powers of the variables should be non-negative integers in every term present in an expression. A polynomial may contain any number of terms, one or more than one. Now, before moving to know how we will find out whether a given expression is a polynomial or not, we need to know the concept of degree also. How will you find out the degree of a expression? To find the degree, we need to take the sum of the powers of the variables in each term, and the greatest sum is the degree of the polynomial. Using these examples, I will be telling you whether the given expression is a polynomial or not, and I will be telling you how to find the degree of a polynomial. So let us take this example. 3x plus 5 is a polynomial of 2 terms. How many terms are present in this? 2 terms, and degree is 1. Let us consider this example number 2. This is again a polynomial of 4 terms and degree is 3. How we have calculated the degree? Let us take the first example again. In this, the literal coefficient is x and the power of x is 1, and here no literal coefficient is present, so it will be 0. Only x raised to the power 0 can be considered. So here the highest of 1 or 0, highest from 1 and 0, what is the highest? That is 1. So degree will be 1. Number of terms are 2. This is 3x is one term, 5 is another term. So number of terms are 2, and the powers of the variable present here is x, and it is a non-negative integer, so it is a polynomial. Now if I talk about this second expression, I will be considering every term individually. Let us talk about this first term. How many terms are there? 4 terms. This is very much clear to you. Let us consider first term. In this, the coefficient of literal coefficient, the power of x and y both is positive. Coming to second term, it is again positive. Third term, again positive. So it is a polynomial. Now, how to find out the degree? If we add the powers of x and y both, it will be 3. Here again it will be 3, y is 2 and x is 1. So total power of this second term is 3. And now coming to the third term, it is for x raised to the power 1, y raised to the power 1. So it will be 2. Now here this is the constant term, so no literal coefficient is there. So out of these 3 terms where literal coefficient is present, what is the highest power? That is 3. So the degree is 3. For every term individually, we need to find the powers of the variables, sum of powers of the variables in each term. And then greatest sum is the degree. Here the greatest sum was 3, so the degree is 3. And this is again a polynomial. Why? Because an algebraic expression is called a polynomial if the powers of the variables involved in it in each term are non-negative integers. Now coming to third example. In this example, what is the literal factor in first term? That is x. What is the power of x? That is 1. It is positive. It is satisfying the condition of polynomial. Now 2 is a constant term. It is also again satisfying the condition. Now coming to the second term, that is 3 over x. 3 over x can be written as 3x raised to the power minus 1. And it is not satisfying the condition of a polynomial because the powers of the variables involved in every term should be non-negative integers, and here it is a negative integer. So this is not a polynomial. Simple as this. And if it is not a polynomial, we cannot find the degree of this expression. I hope this is clear to you. How to find out whether an expression is a polynomial or not, and how to find out the degree of a expression of a polynomial. Now coming to another topic, that is addition of algebraic expressions. When we add two algebraic expressions, we add only like terms. We can add only like terms. This you must be aware, as you have done this addition of algebraic expressions in your previous class. And the sum of two or more like terms is obviously a like term with the numerical coefficient equal to the sum of the coefficients of all the like terms. So let us see with the help of an example. And there are two methods to add an algebraic expression. That is, one is horizontal method and another is column method. You can opt any of these two methods. Both will be correct. So if I need to add, I will be showing you both the methods, horizontal method as well as the column method. If I need to add these three expressions, how will I add using the horizontal method? First of all, I will be writing all the expressions in a horizontal manner. So I have written all the expressions, the complete expression, all the three expressions in a horizontal manner. Then I need to find the like terms. Now in the first expression, first term is 3x square, and in the second expression there is no such term of x square, and in the third expression it is minus 4x square. So 3x square and minus 4x square, these two are like terms. Likewise, we need to find the like terms from all the three expressions and then keep on adding. Let us see how we will keep on adding them. Now here what I have done, I have written the like terms together. These two are the like terms of all the three expressions. These three are the like terms. Then again y square term I have written, and then constant terms of all the expressions. Then after solving, you will be getting minus x square minus 7xy plus 12y square minus 9, which will be the required sum. Simple as this. Horizontal method, I think it will be clear to you. Coming to the column method. Column method, when you are supposed to use column method, you can write the expressions in the same manner I have written like this. This was your first expression, second and third. But one thing you need to make sure that like terms should be written below the like terms. Like in the first expression 3x square I have written, and in the second expression no like term was there, so I have left a blank. In the third expression, the like term is minus 4x square, so I have written below 3x square. Likewise, you must be observing that like terms are written below the like terms, and simply you are supposed to add it. And you will be getting minus x square minus 7xy plus 12y square minus 9, which is the required sum. You can opt either of these two methods, but answer will remain the same. If you are using a horizontal method or column method, answer will remain the same in both the methods. Now, subtraction of algebraic expressions. To subtract algebraic expressions, change the sign of the algebraic expression to be subtracted and then add. As you must be aware that if I need to subtract two algebraic expressions, we need to change the sign of each of the algebraic expression to be subtracted, and then we need to add. Likewise, in this subtraction of algebraic expression, we can use horizontal method or the column method like we have used in the case of addition of algebraic expression. Now, if I need to subtract this expression, given expression, from this, how will I do it? Let us see. Horizontal method I am doing first. So as I need to subtract the first expression from the second one, so second expression will be written first, minus, as I need to subtract, so minus sign will be there in between, 5x cube minus 3x square minus 8. As I told you in the previous slide, that if I need to subtract algebraic expressions, we need to change the sign. So what will be the second step? This first expression will remain as it is. Now you must be observing the sign of every term present inside this bracket will be changed. It is very important to use the bracket. Only then you will be able to, you will keep in mind that you need to change the sign. Otherwise, you can commit mistake sometimes if you are not using the bracket. So my advice is to use the bracket before the second expression, which is to be subtracted. So likewise, sign will be changed of every term. So it will be minus 5x cube plus 3x square plus 8. Now then again same method, we need to add the like terms. So like terms will be written all together. What are the like terms? It is 2x cube minus x cube minus 5x square plus 3x square minus 11x plus 2 plus 8. And after solving, you will be getting this answer. This will be the answer. Minus 3x cube minus 2x square minus 11x plus 10. This will be the answer after solving or after subtracting the first expression from the second one. That is 2x cube minus 5x square minus 11x plus 2 minus 5x cube minus 3x square minus 8. Now let us see column method. In this column method, what I have done, I have written the second expression first expression afterwards, and I need to subtract. As I need to subtract, so I have changed the sign here. You must be observing, I have changed the sign. It was plus, so I have changed it to minus. It was already minus, so I have changed it to plus. This will be written as it is, and it was minus, so I have written here plus. Now you can keep on solving, and you will be getting the answer as minus 3x cube minus 2x square minus 11x plus 10. Answer will remain the same in both the methods. Either you can opt any of the methods, but answer will remain the same. Now, dear children, as you must be aware about your holidays, so you are supposed to check your holidays homework, which will be uploaded in the homework column on the EdQuark site. Now, coming to the homework solutions from NCERT of the previous lecture, I am discussing now the homework solutions. I am solving, dear children, 3 parts here. As it is a very simple question, you will be able to solve the rest of the parts on your own. But I am giving you just an idea how to solve this question in a proper manner. Rest of the parts you are supposed to do on your own. So this is question number 1. Identify the terms, their coefficients for each of the following expressions. These are the 3 parts I have taken here. Now I have written this question in the tabular format, so you can do in the same manner, or you can do in your according to your own wish also. But doing it in a tabular manner is more convenient to understand. So let us see first part, number of terms. These are 2 terms I have taken in the first part. Coefficient of first term will be 5. Coefficient of second term is minus 3. In the second part, 3 terms were there. Coefficient, numerical coefficient I need to mention. So it will be 1, 1 or 1. You can also mention the literal coefficients, though it is not mentioned in the question whether literal coefficient or numerical coefficient is to be mentioned. So here I am showing you numerical coefficient. You can also mention the literal coefficients also, because nothing was mentioned in this question. And for literal coefficient also nothing was mentioned whether we need to find the literal coefficient of x, y, likewise. So it is quite obvious that in this question numerical coefficient is to be written. So these are the 2 parts. This is the third part. Here in the third part, these three terms are there and the coefficient of first term is 4, second term is -4 and third term is 1. As I told you, whenever literal is written all along like x square, its coefficient is taken as 1. So likewise here nothing was written, so it is considered as 1. Coming to the second question, classify the following polynomials as monomials, binomials and trinomials. Which polynomials do not fit in any of these three categories? So dear children, again I have taken few parts. Rest of the parts you are supposed to do on your own. We need to find out of these given expressions which one is polynomial, monomial, binomial and trinomial. Not polynomial, you need to find out monomial, binomial and trinomial, and which do not fit in any of these three categories will be written separately. So this is these are the terms which I have taken and which fall under the category of binomial, monomial and trinomial, because it has two terms, so it is binomial and terms are x comma y. It has one term, that is a constant term, it is 1. Monomial, it is a monomial, because an algebraic expression having only one term is called a monomial. This is your term. This expression has three terms, so it is a trinomial, and these are the terms. And there are certain certain terms, certain expressions which do not fit in any of these three categories. So polynomial which does not fit in any of these categories is this. So this is a multinomial and there is no mention of multinomial to be told in this question. So it is written separately as it was the requirement of the question. So what we have studied in today's lecture, we have learnt about the polynomials. An algebraic expression is called a polynomial if the powers of the variables involved in every term are non-negative integers. Then we have learned to find the degree of the polynomial. Then we have recalled the concept of addition and subtraction of algebraic expressions. So I hope, dear children, you must be able to do the questions that will be given to you in your holidays homework. So thank you so much. Happy holidays and do complete your work well on time. Thank you so much.